next exercise or program that we're gonna build to learn recursive programming with Python. So I have some ideas here that I'm gonna try to translate rapidly, just with command that we're gonna say um, translate please all the 20 program titles to English. So calculation of factorial of a number, Fibonacci series. I have already done all of these programs. So let's say we're gonna start from the number 9, which is a little bit difficult for me, but I have to do them because later I'll come back to study them, the the programs. So I'm gonna create a new document. So let's create the name, counting digits in a number. So let's name it as digit counter number recursive .py, and here I'll paste the name of the programs. So let's start by say that I'm learning also typing, so it's important for me to copy all of this text. So here's a Python implementation of a recursive function to count the number of digits in a given number. So we start by defining the function digit count, and we'll receive a number as parameter, and we're gonna start always with our base case, which is that if the number is less than 10, so it means that it has only one digit. And here I have a function that I don't recognize. If apps number, okay, so this function, it's new for me. I'm asking why do we use apps here? Okay, what is apps short for? So we're gonna answer first question. Comment. Let's answer this one. This will be the first one. It has more sense to be at the beginning. What is apps short for? So let's comment that apps is short for absolute value, and it returns the non-negative value of a number. So abs is short for absolute value, and it returns the non-negative value of a number. For example, abs less minus 5 returns 5, and abs 5 also returns 5. So what is abs short for? Abs is short for absolute value, and it returns the non-negative value of a number. For example, abs minus 5 returns 5, and abs 5 also returns 5. Okay, so if abs number is less than 10, we're returning 1. On the other hand, here we have our recursive case. Let's say divide the number by 10 and count the digits in the quotient. So I'm asking everything that I don't know. Recursive case. So we have a recursive case. Yes, we divide the number by 10, okay, and count the digits in the quotient. Okay, we're gonna return 1 plus digit count number, división entera from 10. Okay, return 1 plus digit count number. Explanation of the code. The function digit count takes a single parameter number. The function digit count takes a single parameter number. The base case checks if the absolute value of the number is less than 10. If it is, the function returns 1, indicating that the number has only 1 digit. In the recursive case, the function divides the number by 10 using integer division. To remove the last digit and calls itself with the quotient. It adds 1 to the result to account for the removed digit. So let's begin with the usage of the program. Sample of usage. So let's create the number. It'll have I don't know what's the difference. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is a number, but what's the number is not defined. Okay, but I'm defining at this moment, right? Number now it's okay. So sample of usage, we're gonna create a count, and then we're gonna use our function digit count, and it will receive our number. Now we're printing that the number, we're giving format to the string, the number has count digits. Let's see if it works. Okay, now it's just as an explanation of the logic. I'll take that logic. It says that the recursive nature of the solution allows us to break down the problem into smaller subproblems, making it easier to solve. It says that each recursive call works on a smaller number until we reach the base case of a single digit number.